Welcome, everyone. Today, we're kicking off our lecture series on AWS, or Amazon Web Services. This is Lecture 3, and I'm excited to have you all here. The title of our session is ComputEra, which will guide us through some key concepts and practical insights. In this presentation, we'll cover the fundamentals of AWS, explore its core services, and look at how it's transforming the way we handle computing tasks. So, let's get started and make this session informative and engaging. In 2013, the Global Certification Program was launched to provide a structured way to validate cloud skills and knowledge. It offers several certification categories, starting from foundational, then progressing to associate, professional, and specialty levels. These categories help professionals demonstrate their expertise across different areas of cloud computing. It's also worth noting that if you're aiming for roles like SysOps or DevOps, you don't necessarily need to pursue the Solution Architect Professional certification. An associate-level certification can be sufficient to move forward in those paths. Now, moving on to cloud service models, these are fundamental concepts that define how cloud resources are delivered and consumed. The three main models are IaaS, which stands for Infrastructure as a Service, providing virtualized computing resources, PaaS, or Platform as a Service, offering a platform to develop, run, and manage applications, and SaaS, Software as a Service, where software applications are hosted and accessible over the internet. Beyond these, there are additional service models like FaaS, Function as a Service, which enables serverless computing, DBaaS, Database as a Service, CaaS, Container as a Service, BOS, Backend as a Service, and many others, including XaaS, which stands for Anything as a Service, covering a broad range of cloud offerings. The key benefits of adopting these cloud models are scalability, allowing resources to grow with demand, cost efficiency, since you pay only for what you use, accessibility, providing access from anywhere, and maintenance-free operations, reducing the burden on your internal teams. To quickly recap the previous lecture, we covered the foundational concepts of cloud computing, setting the stage for understanding these service models and certifications. These elements are all interconnected, helping us build a comprehensive understanding of cloud technology and how to leverage it effectively in our careers. Let's take a closer look at the cloud deployment model. This is essentially about how your cloud infrastructure is set up, where it's physically located, and who has control over it. In other words, it answers the key question: for whom is the cloud environment dedicated? Cloud deployment models describe how and where cloud services are hosted, managed, and accessed. They help us understand important factors like who owns the infrastructure, how resources are shared, and what security levels are in place for different organizations. There are several main models to consider. First, we have the public cloud, which involves shared infrastructure managed by a third-party provider. That means multiple organizations share the same environment. Then there's the private cloud, which is dedicated to a single organization, offering more control and isolation. Next, we have the hybrid cloud, which combines both public and private environments, giving flexibility and scalability. The community cloud is shared among organizations with similar needs, often within the same industry or sector. Lastly, multi-cloud refers to using services from multiple public cloud providers, allowing organizations to avoid vendor lock-in and optimize their resources. Understanding these deployment models helps us choose the right setup based on our specific needs, whether that's control, cost, security, or flexibility. This is fundamental to designing an effective cloud strategy that aligns with your overall IT goals. So this slide shows the most common model of cloud computing, which is the public cloud. In this setup, the cloud resources like servers, storage, and other infrastructure are owned and operated by a third-party cloud service provider, or CSP. These resources are then delivered over the public internet, making them accessible from anywhere. One of the key points here is that these resources are shared among multiple organizations. This is what's called a multi-tenant environment, meaning many different users or companies are using the same infrastructure simultaneously. Now, what's really transformative about the public cloud is how it changes the way organizations of any size can access IT resources. Instead of owning and maintaining hardware on site, you can instantly tap into a vast, on-demand pool of resources, whether it's servers, storage, networking, or even advanced software applications, all over the internet. And these resources are owned, hosted, and managed by leading third-party providers, which shifts the technology approach from a capital-intensive model to a more flexible, scalable one. This fundamentally changes how businesses think about their IT infrastructure and allows for rapid growth and innovation without heavy upfront investments. So, in the context of our overall discussion, the public cloud exemplifies how cloud technology democratizes access to powerful resources, making it easier for organizations to adapt and thrive in a digital world. Now, let's explore the concept of universal and immediate access to enterprise-grade resources. One of the most transformative aspects of the public cloud is what we call democratization of technology. Essentially, it means that the massive capital expenditure, CapEx, that was once needed to build and maintain powerful IT infrastructure is no longer a barrier. Today, whether you're a startup, an individual developer, or a large enterprise, you can access the same world-class computing power, storage, and global network with just a credit card and an internet connection. This shift levels the playing field, enabling innovation at an unprecedented scale. Moving on, another key point is self-service provisioning. Thanks to intuitive web portals and APIs, users can deploy entire server infrastructures, software applications, databases, and AI tools in just minutes, something that used to take months. This ease of access empowers teams to experiment, innovate, and scale rapidly, turning ideas into reality much faster than ever before. And finally, the global reach combined with local presence. Major cloud providers like AWS, Azure, and Google Cloud operate from a vast network of secure data centers around the world. This means any organization can deploy applications in various regions worldwide, ensuring low latency and a better experience for international customers. All of these features, democratization, self-service, and global reach, are key to understanding how the public cloud is transforming the way we access and utilize IT resources, making enterprise-grade technology accessible to everyone, everywhere. Let's talk about the shared responsibility model, a core concept in the public cloud. Essentially, it's a framework that clearly outlines who is responsible for what when it comes to security and maintenance. This clarity helps us achieve much greater operational efficiency. On one side, we have the cloud provider. Their responsibility is to ensure the security of the cloud itself. That means they're in charge of the physical security of the data centers, the integrity of the hardware like servers and disks, and the core network infrastructure. They also handle the hypervisor and make sure their global infrastructure is physically isolated. In simple terms, they're responsible for building and maintaining the secure foundation that all cloud services rely on. On the other side, our responsibility is to secure what we put on that foundation. That includes protecting our data, setting up proper identity and access management policies, managing our operating system configurations, and ensuring our applications are secure. It's really about what we do with the cloud, what we put on top of that foundation. Understanding this division of responsibilities helps us unburden our IT teams, letting them focus on what matters most, managing and securing our unique assets within the cloud environment. Let's talk about unmatched reliability and expert support, which are critical benefits of cloud services. First, consider hardware worries. If a physical server fails, or a network switch stops working, or a storage drive degrades, it's the provider's automated systems that step in. They detect the issue, replace the faulty component, and remediate the problem, often without you even noticing. This built-in redundancy and resilience mean you get exceptionally high levels of uptime and business continuity, keeping your operations running smoothly without disruption. Now, on the support side, when you encounter software configuration issues, performance bottlenecks, or platform-specific challenges, you're not left on your own. You have access to the provider's 24/7 expert support teams and a vast knowledge base. Instead of troubleshooting hardware issues yourself, you can engage with specialized engineers, architects, and solution experts who are ready to help. They assist in resolving issues and optimizing your environment for performance, cost, and security. Overall, these features, automated hardware management and round-the-clock expert support, are key to ensuring your cloud experience is reliable, secure, and efficient, aligning perfectly with the overall goal of providing a seamless and resilient infrastructure. So, for FlashFrame, a startup venturing into the video streaming world, the challenge was clear. They needed a robust, global infrastructure capable of handling unpredictable and viral traffic spikes without any upfront investment in physical servers. Performance had to be seamless worldwide, and they needed to deploy their platform quickly to stay competitive. Their solution was to build the entire platform on a public cloud, whether that's AWS, Google Cloud, or Azure, giving them the flexibility and scalability they needed. They rely on cloud services like AWS EC2 for compute power, S3 for storing their videos, and CloudFront for delivering content globally. What's really powerful here is that there are no physical servers involved. Everything is virtual and managed entirely by the cloud provider, which means they can focus more on their content and less on hardware management. And when it comes to scalability and costs, the cloud is a game changer. The platform automatically scales up during peak viewing times, say, after a popular show drops, ensuring a smooth experience. Then, it scales back down during off-peak hours, which helps control costs because they only pay for the resources they actually use. This setup gives FlashFrame instant global reach, unmatched scalability for viral growth, and allows them to concentrate on creating great content and enhancing user experience, instead of worrying about managing hardware infrastructure. Let's delve a bit deeper into the core technologies that underpin private clouds. You might be familiar with terms like Virtual Private Cloud, or VPC, and Virtual Private Network, or VPN. While both are fundamental, they serve different purposes. A virtual private cloud is essentially a logically isolated section within a cloud provider's network. It's like having your own dedicated corner in a shared cloud environment, where you can launch your resources such as servers and databases. Even within a private cloud, segmentation using VPCs allows you to create subnets, control traffic through firewalls, and enhance security overall. On the other hand, a virtual private network is a secure, encrypted tunnel that connects you remotely to that private network. For example, employees working from home would use a VPN to access applications inside the company's private cloud securely. Understanding these technologies helps us see how private clouds offer both control and flexibility. They enable organizations to meet strict data sovereignty and regulatory requirements while maintaining the agility and scalability that are hallmarks of cloud-native architectures. Let's talk about the term enterprise cloud. Calling it an enterprise cloud is really fitting because it's specifically designed for large organizations, those that need absolute control over their infrastructure. These organizations often have strict security and compliance requirements, like HIPAA or GDPR, and they need to customize their systems deeply. Essentially, it's like extending their own data center, but with the agility and scalability that cloud solutions offer. Moving on to control and confidentiality. This is one of the main reasons organizations choose private clouds. It's all about data sovereignty and security. When you set up a private cloud, you physically own or rent the hardware exclusively. That means your sensitive data stays on hardware that only you or your organization use. Unlike public clouds, where multiple tenants share resources, private clouds eliminate that shared environment, reducing major security risks. Now, let's consider the operational model. Managing a private cloud isn't just about having the hardware. It's about the ongoing management, maintenance, patching, and support. This shifts a lot of responsibility onto your IT team or a managed service provider. This is what we call operational overhead. It's definitely higher than in a public cloud, where the cloud provider takes care of most of those tasks. Finally, security and flexibility are key advantages here. Because you control the entire environment, you can implement any security measures you need, any tools, any network architecture, any access policies. You're not limited by what a cloud provider offers. This level of control enables you to create tailored security postures that comply with strict internal policies or regulatory standards. So, in essence, private clouds give large organizations the control, security, and customization they need, but with the responsibility of managing the infrastructure themselves. Let's talk about ultimate control and customization. When you choose a private cloud, your organization has complete authority over the hardware, the network, storage, and virtualization layers. This means you can create highly tailored configurations that are specifically designed to run legacy or proprietary applications. These are often applications that might not play well in a public cloud environment, so having this level of control is a significant advantage. Now, security and compliance are often the primary reasons organizations opt for private clouds. By leveraging physical isolation, you can achieve a hardened security posture that's difficult to match with public clouds. This is especially important in industries with strict regulatory requirements, like finance, healthcare, or government. Private clouds help ensure data sovereignty, meaning you control exactly where your data resides, and make audits much easier because everything is centralized and compliant with standards like PCI DSS or HIPAA. Moving on to predictable performance. Since the resources in a private cloud are dedicated and not shared with other organizations, what we call noisy neighbors, performance remains consistent and reliable. This is critical for high-performance computing, large databases, or applications that need low-latency connections to on-premises systems. You can count on steady, predictable results. Finally, operational efficiency. While private clouds require a bit more hands-on management than public clouds, they are a substantial upgrade from traditional siloed data centers. They introduce self-service portals, which allow developers and departments to provision resources like virtual machines or storage on demand without waiting for it to set everything up manually. This reduces delays and accelerates project timelines. Additionally, resource pooling enables IT teams to manage a large pool of compute and storage resources dynamically. As needs change, resources can be allocated or reallocated across projects or departments, boosting utilization rates overall. So, in essence, private clouds give you the control, security, performance, and operational flexibility you need to meet complex, demanding workloads while maintaining compliance and efficiency. Let's take a closer look at how QuantSecure approaches their private cloud setup. As a hedge fund specializing in proprietary algorithmic trading, their algorithms are incredibly valuable intellectual property. They handle massive amounts of real-time, market-sensitive data, which makes security and speed absolutely critical. Using a public cloud for this would introduce too many risks, both in terms of security and latency. Public clouds, while flexible, can be less predictable and potentially expose sensitive data. So, QuantSecure chose to invest in an on-premises private cloud, leveraging platforms like VMware. This means they have their own data center equipped with powerful servers, high-speed networking, and dedicated storage arrays. Having this infrastructure on-site gives their IT team complete control over the hardware, hypervisors, and network security. This creates a highly isolated environment, so their algorithms can run without any risk of exposure to other tenants or external threats. The key benefit here is that they get the best of both worlds. They enjoy resource pooling and self-service capabilities, so their quants can quickly spin up virtual machines for testing, while maintaining ultra-low latency trading and maximum protection of their intellectual property. This setup truly exemplifies how private cloud solutions can meet the demanding needs of high-stakes financial trading.